Very good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 7th students for today's session. As you can see on the screen, and you are well aware, my subject is physics. We are in class 7th. Our ongoing 7th chapter, light. Today we are entering into the session number 2. So we started this class on Tuesday, the chapter, which is the penultimate chapter, last but one chapter of the material. So we'll continue where we left in the last class. But before that, let us recall, let us review what we learned about the chapter in the last class. In last class, we discussed about the few important terms related to light. Some important terms, because about light you already learned in the class 6th, the basics. As you all know, light is a form of energy which makes the object to visible for us, or which creates the sensation of vision by falling on retina, right? So then, just re-glancing of the important terms of light, reflection of light. As you all know, some materials, when light falls on them, they reflect the light completely, which are called opaque. They does not allow the light to pass through them. So they are called opaque substances. That is, the bouncing back of light is called as reflection. The property of bouncing back of light when falls on a hard surface. Right? You have seen. Then what is a mirror and reflective light? A mirror is a shiny, polished object. Shiny, polished object, I already told, which is your shaving mirror or a mirror you can see in your face daily morning, which is finely polished and one end is coated with the material, suitable material, right? Then image, you are familiar. So image is same replicant of object, which you can see through the mirror. An image is that formed in front of the mirror and can be obtained on a screen. Which is obtained on a screen is called real image. Not obtained on screen is called virtual image. So real classes which are happening in your school, your teachers are teaching in classroom, are the real classes, whereas I am teaching through is called virtual classes. They are called virtual classes, right? Because it is not real. You cannot catch me. You can catch your teacher, right? That is virtual images. My image is virtual for you. Plain mirror, again same, a mirror having flat surface. So see, mirror can be very flat. This is one case. Mirror can be curved inside. Mirror can be bulged outside. Just like a spoon, I told na. Spoon. Spoon, two types are there. One is, both are the curved surfaces. They are called curved mirrors. Whereas flat surface one is called plain mirror, which will see our faces at home. Right? The plain mirror is having some important characteristics. When you stand in front of the mirror, your image is found on the other side of the mirror, which you cannot catch. So it is a virtual image. So color, height, size of yours and your color or your color of dress, everything is same as a object. You and your image also having everything same. The distance from mirror to image and mirror to object is same. If you move back, your image also move back. If you come front, image also will come front. In case of plain mirror. Whereas spherical mirrors. So spherical mirrors two types, which are obtained from a hollow sphere. You know, hollow sphere means just like your rubber ball, right? So suppose say this is a rubber ball, which is hollow sphere. When you cut that, into two parts. So one will be like this and other will be like this. In one kind of spherical mirror, inner part is a reflecting surface. In some, outer part is a reflecting surface. Right. So inner part is reflecting surface is called concave mirror. Outer part is a reflecting surface called convex mirror. Simple. Right. It is a part of mirror, part of a spherical mirror or part of a sphere where the reflecting surface is curved. Reflecting surface is curved. Curved are two types. Inner side curved or outer side curved. So, based on that, the spherical mirrors are classified into concave mirrors and convex mirrors. Right? Very simple. These are the 10 important terminology regarding the light. So, everywhere you come across these words, you need to remember them forever. Okay. Now, move to some more extension, which we already discussed in the last class a little more about the reflection at spherical mirror. Reflection of spherical surfaces. How reflection takes place. See, very simple. Curved surfaces or curved mirrors. You know, curved mirrors are two types. So it is a part of small halo sphere. This explanation is given for that. Halo sphere whose one side of surface is polished. One side is internally polished. Outside is reflecting surface. Right? Here, this when you take another one, polished, then the outer surface becomes the reflected, is called convex mirror. Right? If its outer surface is silvered, then its inner face is become reflecting, is called concave mirror. So one side will coated with the paint. Other side acts as a reflecting surface. Right? So in your sphere, when you consider the two parts, one's internally painted with silver, one is outer externally painted with the silver. The silver coat painted part, other than silver coated, is acts as a reflecting surface. Right? One is inward, other is outward. Such mirrors are called curved mirrors. You can see here. Convex, concave. Okay. There are two types of the curved mirrors, which are the part of sphere, which are the part of a hollow sphere, we can say. You take glass hollow sphere, glass ball, like that. You can cut it, and one side of outside is coated with silver. Where inner part is acts as a reflecting surface called convex mirror. One internally coated with silver, outside part acts as a reflecting surface called concave mirror. Clear? Then, after observing the reflections, we already learned in the 6th class, laws of reflection. Suppose we have one reflecting surface, either it is curved or plane. So we are incidenting the light on mirror here, and it is reflect back as per the definition. Here, when you draw a perpendicular here, it is called normal. Normal is the perpendicular drawn from the point of incident or reflection. Right? So this is called incident ray, this is called reflected ray, this is called normal ray. So in this process, whether it is a plane mirror or curved mirror, the incident ray, reflected ray and normal reflecting surface at the point of incident are coplanar, or lying on same plane. See here, incident ray, reflected ray, normal. They are all lying on same plane only. Correct? All lying on same plane. The second one is angle of incident is equal to angle of reflection. What is that? Angle made by incident ray with normal is called angle of incident. Angle made by the reflected ray with normal is called angle of reflection. With what angle the light incident here, the same angle it reflects back. That is, angle I is equal to angle, or always Very, very important law. First observation is incident ray, normal, reflected ray lies on same plane. They are coplanar. Coplanar is lying on same plane. The angle of incident is always equal to angle of reflection. That is, the angle made by incident ray with normal. Angle made by reflected ray with normal. Both are always same. If we increase the angle of incident, angle of reflection also increases. If you decrease the angle of incident, angle of reflection also decreases. Clear? And third, one more is not given here is always see incident ray and reflected ray always on the either sides of the normal. One is at left, one is at right. Right? Always. Always incident and reflected ray on either sides of the normal. Normal is always at the center only. These three together called as laws of reflection. What are they called? Laws of reflection. Clear? So before going for the further, let me show you one video on this. Then we'll go for the general terms and all.
Till now, we have been looking at the properties of images formed by plane mirrors. A plane mirror is a mirror whose reflecting surface is flat. What about this mirror? Is this also a plane mirror? This is a mirror as it has this smooth reflecting surface. But this is not a plane mirror as this reflecting surface is not flat. The reflecting surface is curved and hence this mirror is called a curved mirror. What about this one? This is also a curved mirror. The difference between the two is that the reflecting surface of this mirror is curved inwards, whereas the reflecting surface of this mirror is curved outwards. Can you think of examples where you have seen curved mirrors? A shiny surface of a spoon is a good approximation of curved mirror. Spoon has two reflecting surfaces, one curved inside and the other curved outside. Now, the specific types of curved mirrors that we are interested in are called spherical mirrors. In fact, these two mirrors are spherical. Well, they look nothing like a sphere. But then why are they called so? They are called spherical mirrors because their reflecting surface is a part of a sphere. You can clearly see that the reflecting surfaces of both the mirrors form the part of the sphere. Now, both these are given special names. The mirror that has its reflecting surface curved inwards is called a concave mirror, and the mirror that has its reflecting surface curved outwards is called convex mirror. Yes, inwards, concave, and outwards, convex. Now we want to study the properties of images formed by spherical mirrors. But before that, we need to define certain terms related to spherical mirrors.
That's what we are going to learn next.
So let's do that. Both the mirrors are placed like this. Concave mirror on your left and convex mirror on your right. I'm going to define the terms for both these mirrors. Concave, inwards, and convex, outwards. The center of the reflecting surface of the mirror is called the pole. We represent it with a point P. In the front view of both the mirrors, you can see that the pole is present right at the center. Now, as I told you, the reflecting surface forms a section of the sphere. This sphere must have a center. This center of the sphere is called the center of curvature, denoted by C. And what will the radius be called? Yes, it's called the radius of curvature. Join the pole and the center of curvature with a line. This line is called the principal axis. The midpoint of the line segment joining the pole P and the center of curvature C is called the focal point. It's denoted by the letter F. We will talk about one last thing in this video. And that is an assumption that we are making all along. We are assuming the radius of the curvature of a mirror to be much greater than the aperture of the mirror. Aperture, in simple terms, is that part of the mirror which is exposed to light. In our mirror, this is its aperture since the light can be incident anywhere in this region. If we hide some part of the mirror with an opaque substance, then its aperture is reduced. Mathematically, it is this length. So the mirror that we are considering is the one in which the aperture is much smaller than the radius of the curvature. These were a few of the terms related to spherical mirrors. But there's a lot more we need to understand about them. See you in the next video.
Right. What now? One more I'll show you. Clearly explain what are the terminology.
Till now, we have been looking at the properties of images formed by plane mirrors. I'm going to define
that is. Anyway, both are they're explaining the same thing, that is about the mirrors, that is about general terms used in the spherical mirrors. So before that, we can see this. Some new word is given here after knowing about the spherical mirrors, which are the part of hollow sphere. One is inward, having the reflecting surface. One is outward. One is called concave mirror, other is called convex mirror. Right. Then paraxial rays and paraxial approximate is nothing, no use for us. The ray which can be closer to the principal axis and make small angle with the principal axis are called parallax rays. That will come across when you know about the parallax axis. Next terms are there, that we'll discuss. Some are called marginal rays. So before that, we learn the terms, important terms related to the spherical mirrors. The first one is the pole. Just I shown pole. Suppose we know that the mirrors are cut from the sphere, right? From here they obtained. One is concave, one is. So where is the center here? The center. So from center to the center of the reflecting surface of either concave or convex is taken as a pole. This is called pole. That is, the geometrical center of spherical mirror is called pole. Geometrical center is this one in a sphere. If you imagine this is a hollow sphere from where the spherical mirrors are the part, this is the center, which is called as a pole, denoted by P. The center of the imaginary sphere for which the mirror belongs to is called center of curvature. The center of curvature of the concave mirror is front of but the center of curvature of the convex mirror is behind. Means it depends on the reflecting surface. So where is inner reflecting surface is there, it is front. Outer reflecting surface is behind, center of curvature. Then radius of curvature. It is the radius of imaginary sphere. This is radius. Imaginary sphere for which the mirror is a part. The distance between pole and center of curvature. So this is called the radius of curvature. This is pole here. Sorry, pole not here. Radius of curvature. Aperture is a point, a small point where is the incident ray falls. The total, there is a reflecting surface. There are so many points may be there. But one point, small point where the incident ray falls and reflects is called aperture. A straight line passing through the pole and center of curvature. Like this. So this is a center of curvature, is a pole. And imaginary passing through this is called principal axis. Either it may be concave mirror or a convex mirror, no matter. An imaginary line passing through center of curvature and pole is called principal axis, small p. Very, very important terms they are. It can be useful in the everywhere. Unless this chapter is completed, we can use this terminology. Center of curvature, radius of curvature, aperture, and principal axis, which you already seen in the video also. Right? As move forward. Principal focus. The principal on the point on the principal axis at which parallel rays coming from the infinity converge after reflection is called focus. See, the rays are coming from somewhere and they are falling here. See, they are falling on the reflecting surface. 3 rays are there. What happened there? After reflection, they are meeting at one point. Okay, here also. It is the case of concave. Diverging mirror they are called. So the incident rays are falling and reflecting back. And they are meeting, imaginary to meeting this point. See, for one, the principal focus is in front, for other one it is behind. This is only imagine, we are imagining that the reflected rays can be meet at this point by extending the rays. This is called the principal focus. The point where all the rays converges after reflection from the reflecting surface. It may be front of the mirror, it may be behind the mirror. So where there is a conversion, light converges, that mirror is called converging. Concave is called converging. Concave mirror converges the light, whereas convex mirror diverges the light. That's why it's called diverging mirror, converging mirror. Right? The point where all the rays falling on the reflecting surface converges or diverges is called principal focus. Capital F, very important point along with these four, along with the pole, principal axis, and aperture, and radius of curvature, and center of curvature. These are the very important points. And one more last one is focal length. Very, very, very important for us. Focal length is the distance between principal focus and pole. So focus to pole. See, this is the pole, right? This is pole. Where is focus? F, where all they converge. So the distance, these two is called focal length of the mirror. Very, very important focal length. Focal length of the mirror, which is generally half of the radius of curvature. Generally, we say F is equal to R by 2. Or radius of curvature is 2 times of focal length. Very famous formula for solving many problems of this particular chapter. That will come across later. Right? That is focal length. So these all are the terms: focal length, principal focus, center of curvature, radius of curvature, aperture, and principal focus. Pole. All these are the important terms will come across when you are studying about the curved or spherical mirrors. Curved or spherical only. There should be some imagination. That is, if they are the part of hollow sphere, when you are cutting from the hollow sphere, the center of the sphere, the imaginary center of the sphere is taken as a center of curvature, right? And the distance from pole to the center of curvature is called radius of curvature. In imaginary passing through pole and the center of curvature is called principal axis. Then the rays will fall on the reflecting surface and either converge or diverge at a point is called principal focus. The distance between pole to the principal focus is called focal length, which is always half of the radius of curvature. Either cases, either in convex or concave. So concave is called, convex is called converging mirror, concave is called diverging mirror. Converging means it converges the light. Diverging means it divides the light rays. Both are having their own applications. They are having their own applications in our day-to-day life. You can see car headlights, torch lights, or dentists use the torch to focus on that a small parts of the teeth. That is one kind, that is converging. Headlights are diverging. Many more are their applications of mirrors. Okay. There are some rules are there here, maybe around 5 rules. Rules of obtaining the rules for obtaining the images found by the spherical mirror. Images found by the spherical mirror. See, both simultaneously given, observe carefully. Any ray of light traveling parallel to the principal axis. Very interesting. Parallel to the principal axis of a spherical mirror after reflection passes or appears to pass through the principal focus. See, parallel. We are getting the parallel line. Observe carefully. This is the principal axis. A line passing through the center of curvature and pole, imaginary line. It's called principal axis. Whenever to this axis, when your parallel ray is incident, when you are incidenting parallel ray, after hitting the point, it is passed through the focal, principal focus. The reflected ray passed through or appears to pass through the principal focus. There is a compulsory observation you have to make. There is a rule. That's all. We cannot change it. It's a rule. We cannot break. Whenever a ray of light is parallel to the principal axis, after reflection, either it passes through the focal or appears to pass through the focus, whether it is a convex or concave. Rule number 1. Second rule. A ray of light that passes or appears to pass through the principal focus after reflection will travel parallel to the principal axis. Reverse. One time, first what you have done, we focus parallel to the principal axis. So it passes through the focus. Second time, we are passing through the focus. When light is directions, you can see. Passing through the focus, after hitting, it will go parallel to the principal axis. If you pass the parallel to the principal axis, it passes the focus. If you pass through the focus, it will come parallel to the principal axis. Vice versa. Right? Both cases, it is satisfying. Both are similar cases but reciprocal. Now when you come to the third one. A ray of light passes or appears to pass through the center of curvature of mirror after reflection will retrace its path. Retrace. See, here when you are passing a light from center of curvature C, passes. After hitting, what happened? It bounces back along same line. That is called retrace. It retraces. See here. We are focusing here. It is retracing along the same direction. Means when you are focusing incident ray from center of curvature, after hitting the reflecting surface, it traces back along the same line. That is third observation, third rule. Okay. And fourth one. A ray of light which is incident at a pole of mirror, convex or concave, is reflected back by making same angle with the principal axis. That is, angle of incident is equal to angle of reflection, even satisfy here also. Suppose, see, you are incidenting the ray like this with some angle, say theta. After hitting the pole, they again reflect back with the same angle theta. Either it is a concave mirror or a convex mirror. These are the few rules of image formed by the spherical mirror or curved mirror. Spherical or curved mirrors, right? So more we'll discuss in next class along with the diagrams, nature, very important this is, nature, position and size of the images found by the both concave and convex we have discussed. Lot are there. Very interesting part of the chapter. This is very much helpful for you in any competitive examinations. The terminology of the spherical mirrors, because now we are discussing mirrors. When you go next, we'll go for the lens also. Lenses are different from mirrors, right? The nature, quite opposite both are. But these terms are common for everyone. Focal length, principal focus, principal axis, aperture, radius of curvature, center of curvature, and pole. All common for lens and mirrors. There will be some changes, but terms are same. So you need to recall them, you need to remember them, you need to understand them practically. So we'll see some more videos in the next class before entering into the next two part of that is to know about the nature of the mirrors, image found by the spherical mirrors, right? So that's all for today. We learned a lot from the chapter light in this section. So thank you, students. Have a wonderful day. Thank you.